Hi everyone! Today, we're diving into a common code review topic, making your Python unit tests cleaner and more robust. Specifically, we're going to talk about how to avoid those often cluttered try/except/finally blocks within your tests. While try/finally is essential for resource management in application code, using it extensively in unit tests can make them harder to read and maintain. Let's explore a better approach that leverages the power of the unit test framework itself. You often see try/except/finally in tests when there's a need to set up a specific environment or resource before a test runs, and then ensure that resource is properly cleaned up afterward, regardless of whether the test passes or fails. For example, a test might need to create a temporary file, write some data to it, run a function that reads that file, and then delete the file. The finally block guarantees the file deletion, preventing leftover test artifacts. Or perhaps a test needs to open a database connection, perform some operations, and then close the connection. The finally block ensures the connection is always closed. While this pattern works, it adds a lot of boilerplate code directly into your test methods. This boilerplate can obscure the actual test logic, making it difficult to quickly understand what a test is actually verifying. Imagine having many such tests, each with its own try/finally block. The repetition and visual clutter can be significant. Fortunately, Python's UnitTest.test case class provides dedicated methods designed for exactly this purpose: setup and tearDown. These methods are powerful tools for managing test prerequisites and cleanup. The setup method runs automatically before each test method in your test case class. This is the perfect place to put all your setup logic. If you need a temporary file, create it in setup. If you need a database connection, open it there. If you need to mock certain objects, do it in setup. Conversely, the tearDown method runs automatically after each test method, even if the test method itself raised an exception or failed an assertion. This makes tearDown the ideal place for all your cleanup code. Delete the temporary file here. Close the database connection here. Unmock any objects you mocked. By moving the setup and tearDown logic into these dedicated methods, your individual test methods become much cleaner and more focused. They can concentrate solely on the specific actions and assertions that define the test's purpose. This separation of concerns greatly improves readability and maintainability. Consider another powerful Python feature for resource management: context managers, used with the with statement. For resources that are scoped very narrowly to a single operation within a test method, a with statement can be highly effective. For example, with open, my_test_file.txt, w, as f, ensures the file is automatically closed when the with block exits, even if errors occur. You can even create your own custom context managers for more complex setup/tearDown scenarios that are specific to a function call within a test. However, for resources that need to persist across multiple test methods within a test case, or for setup that applies to the entire test class, setup and tearDown remain the preferred solution. The main goal here is to keep your test methods concise, clear, and focused on the actual test logic. By externalizing setup and cleanup, you reduce code duplication, make changes easier to manage, as setup/tearDown logic is in one place, and ultimately create a more robust and understandable test suite. This approach is a cornerstone of good unit testing practices and significantly enhances the quality of your code review feedback. So, the next time you find yourself writing a try/except/finally block inside a unit test method, pause and ask, can this be moved to setup or tearDown? Or can a context manager simplify this specific operation? Adopting these patterns will make your tests far more readable, maintainable, and professional. Thanks for watching this video. I hope you found these tips on improving your unit test structure helpful. If you did, please give this video a thumbs up, and don't forget to subscribe for more coding insights and best practices. See you next time.